Okay, so today I'm going to replace a Reelstand encoder. The first thing we need to do is test it. So I'm going to bring this arm up so that it thinks it's the running arm. Okay. I'm going to go to diagnostics, face simulation, simulate, drive enable, and I'm going to increase the speed here. And the speed here should match. Now this one is particularly difficult because every test that I do on it shows that it's good, but I have noticed it jump once. Now normally I would just leave this, but because we keep on losing pacers on this reel, we're going to go ahead and replace this anyway. But if I saw this jump out of range like quite a bit, so as it was climbing, if it went to like 1200 or you know, back down to 500, then we would know that it's bad. But according to this, it's good. Yeah, there's no issues there. See that chuck spinning. So I'm just going to bring this back down to 0 and watch it decelerate. Tried to do this a couple of times just to see if we get any different results, but according to this it looks good. The only hunch I have, like I said, is because I saw it jump once while I was pasting and then we lost the paster, so that's what we're doing now. Okay, so bring this back down a little bit. We want to try to make it comfortable for us to work on it because we're going to shut the power off and we are not going to be able to move this after that happens. I just want to have plenty of room for myself and being able to get to that encoder, which is right there. Power off. So sometimes these are cut to allow me to get access here. I'm not sure if I'm actually going to be able to pull this plate off. I might have to take this entire assembly off, but we'll find out. This is the encoder, and it's attached by a coupler here. So there's the shaft, and then a coupler, and then the encoder. And we have to release that coupler before we pull this off, otherwise we'll damage it. You kind of see this gap right here. So that's where the coupler is. And then if I spin the fan on this motor, it'll spin that coupler. And I can see one set screw right there. If we look in there now, we can kind of see that set screw right here. There's one here and one on the other side. Just need to break it free. And we don't need to do both sides, we just need to do one side. So I got this one here, and then we need to spin it again because there's going to be another one just like it. And that is our smallest metric Allen wrench. That is a 10 millimeter. Might just be able to squeeze that off. Alright, so this is going to have to come off. So, shut off the air. I think I can get away with just loosening this enough to get that out. Too much. Okay. So now the encoder is held on with 3 screws on the inside here. Just like that. You can see it's these tiny little screws on the inside and they just stick in right there. And it threads right into the end of the encoder. So here's a new one. It is a little bit different. The wires are a little bit different, but it works just the same. This is a Kubler 05.2400.1122.1024. And it is, so that's a 1024 steps, and this is an incremental encoder. The rest of the numbers, I have no idea what they are. Let's play this off. We want this slot to be facing up, and we want the wire to be facing up. You can kind of move that around a little bit, and if we do it like that, we're not going to run into a situation like this where we're wrapping the wire around it. So it'll just go from here straight up into the power box. And make sure you got that lined up right. And then we'll thread that in. You want to be careful not to strip these screws because the heads on these are fairly soft. The only way that I know to get these things in is just to kind of maneuver them in and then grab it, kind of rotate it in. Yeah. So this is physically attached. Now we got that tiny little shaft right here on the end, and that has to fit into that coupler, right? We don't want to bend that shaft. We don't want to damage the coupler, so we got to be a little bit careful here. There we go. What we can do here, take this, stick that in, and rotate it under. There we go. And get this started. If you got a shorter bolt, it'd definitely be better to put that in here. This set screw back down. Okay. So we need to attach this wire to this wire. This is a little jacked up because the wiring on the old encoders is not the same as the wiring on the new encoders. Now remember these things being armored. Apparently they are. This one, we got 1, 2, 3, 4, 5, 6, 7, 8 wires. We got 8 wires on this one, but we only use 6 of each. Come to think of it, it's probably better to keep this off. So for the old encoder, we're using gray, pink, yellow, green, red, and blue. We're not going to be using white. We're not going to be using brown. So these two we'll tuck back. And on the new encoder, we're using green, yellow, gray, pink, brown, and white. So we're not using red or blue. So these two I'm going to tuck back. I'll cut off the red and blue on the new, and I'll cut all this short. Should make sure that it is all fairly the same length. And strip this to 22. It's going to go up here. I'm going to kind of shove this behind and zip tie it up a little bit. And I want to leave most of this wire just so that in the future we don't have to mess with this. So the old gray is going to go to the new green. I'm using 3/8 3:1 heat shrink. This is marine grade, so it's going to be able to seal all the oil and stuff. these wire-fi heat shrink splices. They're solder seal connectors. One end. So line up the wires. And hold it in place. Alright, right here I just want to make sure that I'm not melting anything I don't want to melt. I'm just going to give that about a minute to let that cool off and solidify, and then we'll do the next one. Old pink to new yellow. And the further we get into this, the more complicated it gets, because we want to heat the new stuff without heating up the old stuff. We want old yellow to new gray. And there's no particular order that you have to do this in. It doesn't matter. This is just what I'm going with. Green to new pink. We got old red to new brown. Up is old blue to new white. So I'm doing this all at 400 degrees Fahrenheit, which is just pushing too much. I usually want this thing to be pretty hot, just so I can ensure that I melt that solder. Okay. So at this point, you find out if you forgot to put the heat shrink on. If you did, then you have to cut all this and do it all over again. If you had any problems with this thing tearing, you might have to cut it all off and redo it again. There's a lot of things that could go wrong on this, but this one so far went fairly smooth. Now if you pull it straight, they should all be fairly even. If you got one that's shorter than the other one, then anytime this cable gets tugged on, it's going to pull on that one wire. So that's the importance of having everything even when we start. I got a nice long piece of heat shrink on here. And the main reason for that is I want to make sure I have this nice and sealed on both ends, because there are a lot of chemicals and oils and things that occur in here, and we want to make sure we are not dealing with that. Again, the important thing here is making sure that we're not melting anything else while we're heating this up. The plate. Just so you can kind of see what I got. I got the little bundle right there. Now we're going to put the plate back on in front of it. No sparks. Okay, so we got numbers. That's good. See if those paces start improving.